Hello everyone, this is my 17 subscriber special. Wow. Okay, so this problem is called baby's breath, and you're given two permutations called P and Q of a array or a range between 0 and n-1. And here you want to calculate another array, R, which has the same size n, and to calculate R, you have to go through all of its indices, I from 0 to n-1. And so to calculate Ri, you need to loop through all of the indices between 0 and I. For each of those indices, we'll call the current indice value j. You need to find the value 2 to the power of the j's index of p plus 2 to the power of the I minus j, the index of q. And you need to find the maximum of all of those values from j equals 0 to I. And then, finally, you get Ri. And then, here, it's mostly about an optimization, because it's definitely not going to work if you just brute force it. And so, to demonstrate how that works, we can see here, we can see that in the value, when you're asked to calculate the value, you need to calculate 2 to the power of q I minus j. And normally, if this was just 2 to the power of p I plus 2 to the power of q j, well, this would have been very easy. You would have just kept a sort of prefix sum, a prefix max, and just iterated over it and did it in O of n time. But we can't do a prefix sum here, and we can't do O of n time, right? Well, those two things are wrong, and I'll show you the answer to getting this. Okay, so first of all, let's try to run through this sample test case. We're given two permutations, P 0 to 1, and Q, which is 1, 2, and 0. And so, in those permutations, we calculate R by looping through I. So, for the first case, I equals 0, J is between 0 and 1, 0 and 0, so it's just one value. And so, to calculate that one value for I equals 0, we do 2 to the power of p0, which is 2 to the power of 0 equals 1, and 2 to the power of q I minus j, which is equal to 2 to the power of q0, which is equal to 2. And so you add those two together, and you get 3. Okay, so far so good. But then, we go to the second one, I equals 1. And we see two possibilities. So of course, it's going to be pretty difficult since O of n squared, right? Okay, so let's go through this. The maximum, the j's can be 0 and 1 now. And yeah, it turns out if j is 0, it would be 1, the value would be 1 plus 2 to the power of q 1 minus 0. And so that would just be 2 to the power, it would be 1 plus 4, which is equal to 5. If j equals 1, then the value would be 2 squared plus 2, which is 6. And finally, we reach the third one, which is I equals 2. And then, if so, we have 3 possibilities. But I realize that I don't want to go through all of them, so it's just 8. Alright, after that's done, I'll actually get into how the solution is. remember when I said you can't actually use a prefix max? Well, I said that was wrong. But the prefix max needs to be used in a better way than what we previously said. And so, to do this, we first keep track of the index of the highest value of P and Q respectively. And then we get the maximum of them. We see we check if the P max, not prefix max, just the maximum index value of P at this point, which technically makes it a prefix max. Okay, if we calculate the value with J equals that P max, and get the value and compare it to Q max, where J equals Q max, we calculate the values where those two indexes substitute, then we're actually able to get the answer. And so this works because when you're doing one of these problems, when you're comparing these value expressions, 2 to the power of pj plus 2 to the power of that, you first calculate the maximum value of these. And so you compare the maximum value of pj and qi minus j with the corresponding values of the other one. And so, yeah, it works because it's like comparing things based on their highest value digits, but in binary. And so this relates because it basically means that finding the maxes is the best priority, and if you find the max, then it'll automatically be greater than any other possibility. I had a little problem with thinking that there might be two combinations that aren't the maximum indexes, but they still combine to be the actual maximum. But with this system, yeah, with that sort of thing that I talked about, comparing those, that means that it can be proven that there is no such case where that happens. And yeah, as you can see, with some minor tweaks, you can get it accepted. But about the minor tweaks though, I actually got this wrong a little bit beforehand because of a out of bounds or overflow. And so this overflow is caused because obviously you're just, you're getting really high powers of 2, like 10,005, I think, is the highest. And so a minor things that you should, not minor, but something that you should look out for here is to make a sort of array called powers. And essentially what you can see here is, and you can't see here, but powers basically stores the powers of 2 so that you don't need to calculate them wasting time, and because it calculates them incrementally. And so you can apply the modulus to them so that they don't become too large. Okay, anyways, that's the solution. Accepted. And thank you for 17 subscribers. Yeah, I'll try to upload more frequently when I have more motivation. See you.